Okay, so good morning, guys. So let us continue our DevOps Foundational session, day 3. So we would be okay. Sorry regarding yesterday because there was some ad hoc plan, and like I was supposed to go outside, so along with the family, I went and we couldn't do the session yesterday. So today, we have started now the day 3 sessions and the day 4 session today probably at 7 p.m. evening, right? We will have the session. Clear, guys? Okay. So now, okay. So now one more thing, guys, one more important thing. Like while the class starts, like while the class going on, you can always unmute yourself and ask the question. Don't put in a chat because I might not see the chat actually. Okay, I might not see the chat because chat, if I start seeing the chat and all, it will take too much time. So you unmute yourself and ask me any question if you are having, right? Or else if you're having any doubts or if you're not able to understand some concepts clearly or you need any kind of a repetition, please ask me, right? Stop then and there itself. Don't wait for something, like don't wait for or don't expect that okay at the end we'll cover. I mean at the end we'll address. No, whenever you have any doubts you feel to ask, right, you immediately stop me in between. Okay, it is not like I'll get disturbed. No, it is good that if you clarify your doubts and go ahead, right? That is good actually, right? Compared to parking your question at the end and asking, you might even forget some questions also. So if you're not noting down the question and if you feel like at the end I will ask, maybe that question will remain like that. You might not ask also. So I would request everyone to ask the question then and there itself. Don't proceed further without understanding anything. So, okay, guys. So in
Great.
last session, okay, thank you. So in last
Yes.
session, we had covered or we started with some kind of a server terminologies, right? So we try to understand because that this is very much important whenever any person is getting into the DevOps, right? Obviously, he has to learn or understand about what kind of different types of servers we have and what are the terminologies which are involved with these servers, right? Because the DevOps engineer will start playing with these servers. Let it be an application server or the web server or the DB server or any kind of a server might be, right? You will be tend to work with a lot of different types of servers. So you need to understand the terminologies. You need to understand the basic idea behind like what exactly the server is all about and what exactly the server does. So some basic knowledge is required, right? Later you can upgrade your skills a lot in that specific server, but what we are covering as part of this session is that we are just at the very top level, at like from the 10,000 feet level we are understanding what kind of a different servers we have and what exactly that server does. And as a DevOps engineer, we need to understand about that server and the terminologies, how it works, what exactly it provides the service, so on, so on, right? We have to understand. So we started with a few of the servers, like we started with the web server, we understood what exactly the web server, and we also continue to understand about what exactly an application server is all about. And these are the popular web servers which we have in the market when it comes to web server. And the popular web application server, all these are the web application servers actually, right? So the application server, you know that these are nothing but the main your business logic, your application business logic, right? Everything, it will be running as onto the application servers, right? So now, what are the other servers we have? So we will be covering today a few of the things. Like for example, we'll be covering something known as a message queues. This is very important in many organization. We do configure the message queues. We also configure something known as a cache servers. Okay, and you know that we also configure some on the load balancers, right? So these are some of the things which we usually interact in a day-to-day activity, right? So now what we're going to do, and also what we are going to learn after this, like we'll be learning um, about the computing servers, right? This is very much important. Computing servers means like we'll be learning something like client and server architecture, client and server architecture, and you might have heard about something known as a distributed system, distributed systems or distributed server systems, right? And what else you have? In the client server architecture means you'll get everything. You'll get that 3-tier architecture or 2-tier or whatever. That everything comes under this only. And you have something as a peer systems. I mean, yeah. though it is not that much used, but still, I mean, saying that these are some of the computing systems or servers which we have to understand it. Okay, so clear, guys. So what we are going to learn today, we are going to learn about these things. Maybe I am not sure whether we're going to completely cover these things, but if these things are not been covered today, maybe in the evening session we will cover from here. Okay, so we'll see how much possible we'll cover today. Okay, so now what exactly a message queues? Very important, guys. So we will be coming across a lot of message queue systems or message queue servers in our architecture. So whenever working on a project, right, you will be coming across the message queues. Now, where exactly the message queues are used actually, right? So if you want to understand, like, let us open MS Paint. Okay, so we have a server here. Assume that I have some kind of a application server here. So this is my application server. Okay, so assume that here something like a Tomcat server is installed or the Tomcat is running here. So Tomcat server icon, something. So this is the image. So this is a famous image. This is an image, right? You might have seen many times. So basically, this is your Tomcat image, right? So whenever you want to uh, install any application server, right? You can install even the Tomcat server. So this is the icon or the logo, right? So here, what happened, right? Here you are having an application server. Okay, like that you might have many other servers also. So application servers, it's not only one server, it could be multiple server, it could be multiple different applications all together running in the servers. So you will have some more servers, like for example, here you will have some more servers, like you might have a server where something your Python is running, like in the Python, right, you have a Django server. So Django server, right? So basically this is a Django server. So where your Python runs actually, right? Right? And you have some more other servers. Like for example, you can even have a server something known as a what is called as a Microsoft IS server. Like we have Microsoft IS server. Okay. So you have various different applications, different types of applications you have, and all these different applications are hosted in a different servers altogether, right? So and so assume that actually consider that you are having an application where you are working for some medical record system, something like if you go to any kind of a hospitals, right, usually hospitals maintain a lot of records, medical records, right? So maybe like all the patients along with the patient's ID, the details about everything, you will be maintaining in some location. So there is so those application as nothing but we call it as a medical record system, something. Yeah, something in the medical record system. Okay, sorry. So medical record system. I'm just trying to say medical record system. So, so maybe what happened, this application server where the Tomcat is running, right? Here you are running a medical record system. Similarly, what happened, right? Whenever you want to do some kind of a scanning, like ultra scan or the CT scan or whatever the other scan we have, right? All those scanning informations, everything you'll be maintaining in this Django server. Actually. So something like where you will try to maintain some kind of a we use a term known as a radiology. Have you heard of this? Radiology systems, we call the risk system. So this radiology system will maintain all kind of information about the CT scan or the ultra scan, whatever we do for the patients, right? Or for that particular patient or for that particular patient's ID, right? Everything you'll be maintaining here. Similarly, at the end, what happened, right? Once the city record and everything happens, right? So this record has to be maintained in some archival system. So this Microsoft IS server where the archival system should be running here. in many of the federal medical federal, right, what they say that whenever a patient comes to hospital, you need to maintain a record of that patient minimum for 10 to 15 years. In US, if you go, they maintain each and every information about the patient, about all his details, everything in an archive system, even up to the lifetime till the patient die, right? They will maintain it. But in India, there's a rule in the medical association that you need to keep all those details of the particular patients, right? Everything in the archive system minimum for 10 to 15 years. So there are different types of rules are there in the federal medical actually. So like that, what happened, right? In this archive system, all the details about your, about your, uh, about the details about the patients, everything will be maintained here in this archive system. So we have something the three different servers with three different applications all together running, right? Suppose, for example, whenever this application server, there's a Tomcat application server, it want to communicate with the Django server, or it has to communicate with the radiology system. It cannot directly communicate with it because this is completely written in a Java, and this is completely written in the Python actually. So I mean, you cannot communicate, but there has to be a way where the communication should happen. Or else, for example, if the Tomcat server it want to send some data to the Django server, right? It has to send a data to the Django server. It can directly send the data to the Django server or to this radiology system can send the data. But assume that for some reason this server will be down. Assume that. Then what happened? Whatever the data which has been sent, that will get lost, right? Right? Because you might be sending the data through TCP/IP communication or through some HTTP or TCP/IP communication. You might be sending a data. So if this server goes down, you know that you will get a return error saying that error value saying that it is unable to connect to the system because the server itself is down. But what happened, right? Somehow you have to send a message so that even though that server is down, the message should be there. Once the server comes back, the message has to be read by that server. So for that reason, to maintain some kind of a like a reliability in passing the message from one system to the other system, you have something known as a message queues. So you have something as a message queues. You have something as a message queue. So this is something like a message queue. So I might take something. Yeah. Hmm. Supposed to get some good icon, but okay, fine, anything. Yeah. So this is altogether a message queue, okay, which you will have here. Okay. So usually what happened, right? Whenever you want to send any, suppose for example, this application server, it has to send a data to this server, radiology system, saying that, okay, please do ultra scan for some particular patient. So what it does, it sends a message. Okay. It sends a message like saying that, okay, it sends a message saying that, 1 second, it sends a message. It has to send the message saying that please do an ultra scan actually. Okay. So how it does means actually basically it sends a data to this message queue. So this is nothing but it's a message queue, guys. This is nothing but the message queue. So now it sends a message. What it sends a message saying that please scan for ultrasound something or anything, CT scan or ultra scan for particular patient ID, something. So it sends a data to this message queues. Now what happened from this message queue, this message has to be delivered to this server. Okay. Now assume that while sending a data to the message queue by this application server, that Tomcat application server, you might set an expiry time for the message saying that the message will long last for 7 days. Post to 7 days, if none of the server is reading that message, automatically the message has to be deleted. Something like that, you have set the expiry for that message. So what happened, right? When you send a message, you will set an expiry date also, or expiry time also, you will set it actually. So then in that case, what happened, right? What happened, right? The message will come and sit in the message queue, and it will wait for some other server to be read by that message. Until that, the message will be there in the message. So assume that this Django server is went down for some reason. It went for some kind of a maintenance activity, or due to some reason the server is gone down. Still, what happened? Whatever the message has been sent by the supplying server, right? It will still be there in the message queue. It will be waiting for somebody to read. As soon as the server comes up, right? It'll try to go and it'll try to fetch the data from the message queue. Once the message is read from it, the message will be deleted from the message. So this is very important, because what happened, right? Somehow you are maintaining the reliability. It means that actually you are making sure that the data should not be lost during communication between the servers. So this is very much important, guys. And in many kind of a projects, like you take any project, like for example, you take a banking project, or else you take some kind of a insurance project, medical project, or else you might see in some kind of a stock market project, right? You are heavily depend upon the message queues actually, and there are a lot of message queues are there. Okay, so now what happened, right? This server, when it comes up, actually it automatically reads the data. It means that you are, so it doesn't mean that actually, it doesn't mean that if the server is not there, the message will be lost. No, the message queue will maintain the messages, because there is a time expiry being set for each and every message what you send into the message queue. Clear, guys? So now what happened, right? As soon as this Django server comes up, it reads the message and the message is deleted. So you're maintaining a kind of a reliability. So you might get some questions, sir, how it is exactly communicated with different servers. So there is some kind of a protocols are there. So by using those protocols, the message queue was actually right. And if you go to the Google, and if you type the message queue, right? Message queue. You can even go for the wiki link also. So you can go to message queue wiki page. So this has an abundant information of what exactly a message queue is all about, right? And how the message queues works actually, and what are the standard protocol it uses for communication. Okay, right? And then what is synchronous, asynchronous, and these are the system 5 Unix implementation. And this is nothing but this, you need not to worry about all these things. So these are the nothing but these are the message queues which are used in our Unix or Linux systems as part of internal communication. And what are the different message queues which are available today, right? You might have heard about RabbitMQ. You might have heard about many other message queues you might have heard about. These are all some of the popular message queues which are available, right? So one of the very much popular message queue nowadays you might have here is nothing but Apache Kafka, right? Many times what happened, right? You might have been asked to configure the Apache Kafka or to install the Apache Kafka and everything, right? In your DevOps work, right? You might be asked. So Apache Kafka is a message queue actually, one of the very popular message. Clear, guys? So now what we'll do, like, let us write some note on this. Okay. So now, okay. So message queue. So in many cases, we want the messaging across the systems, right? Across the systems to be reliable. It means that there is a guaranteed deliverable of the messages. So that's what we call the reliability, right? Suppose if you are using just a simple, if you are just passing the message through HTTP communication, HTTP protocol or TCP protocol, right? If the server is not up here, what happened, right? The message will get dropped, or what happened, right? The message will be lost. Again, you need to resend the message again once the server comes up. But you cannot do like that, right? Because there has to be a way where you will send the data, but it doesn't mean that the recipient has to receive the data at the same time. It is not really required. For example, suppose I send a message to you, some of you, a message in the WhatsApp actually. It doesn't mean that you should always be available in the WhatsApp online, right? Maybe you might be offline. After some time, you will come back. But once you come back, you will see that I've already sent a message. You can be able to read my data, right? How it is happening? It is happening because of some kind of a message to techniques, right? So WhatsApp is the best example, right? So in that way, what happened, right? You are making sure that the message has to be delivered. A message has to be delivered, and the message should not be failed, or it should not be dropped, right? So it means that you need some kind of a guaranteed deliverables or deliverables, guaranteed deliverables of the message is required. Hence, we are using message queues. Okay. So in many cases, we want the messages across the system to be reliable. Okay, but the major communication protocol like HTTP or like TCP are unreliable, right? It means that for always HTTP and message or the TCP, when you are communicating with the two systems, the two systems should always be available. They should be up and running, right? Okay, fine. So to support reliable messaging and something like guaranteed deliverables, middleware, we have a middleware called as message queues. Queue is used. Okay, message queues used. So what are the popular message queues, guys? Some of the popular message queues which are available. Apache Kafka is very famous, and we had something was an active MQ which was vividly used, and we have something as a rabbit MQ. The list is huge actually. Okay, so we can go here. Yes, Harsh, go ahead.
Sir,
Popular. Yes, sir.
uh, sorry, sir, I forgot.
Mhm. So if you go here, see, I'm just typing popular message queues. You can go to any link actually. You could see that there are so many message queues are there actually. See, IBM MQ, right? IBM Cloud Park for integration, right? MuleSoft Anypoint. So you could see the Apache Kafka. See, Rabbit MQ. You could see that there are n number of message queues are available. But the most popular are this one. These three are the most popular. So you will be asked sometimes to configure and set up everything. Yes, sir. Sir, as I said earlier, don't raise any hand or something. Please unmute and ask the doubts. Clear?
Okay, sir. Sir,
Yes, sir.
Redis is also message queue. Redis.
Redis is a cache system actually. It's a
Okay.
cache system. Whatever we are learning, we'll be learning about next the cache server, right? Redis comes under that category.
Okay, sir. Got it.
Okay. Okay, guys. Okay. So that's all about the message queue. So it's not really like I'm just telling in a very high level. So I'm not telling you like how Apache Kafka works internally or how to install configure. That is the next step we'll be seeing. But I'm just telling you in a very high level what exactly message queue does. Clear? Okay, good. Now, what about the next servers? What we have is a cache systems or cache servers actually. Very important. This also in many like in many industries, like we use the cache systems actually. Okay. Now, one very important question to you, all of you, that in our laptop, if you take in your laptop, right? Generally, which is the very slowest component which works in our laptop or in the server? Which is the slowest component?
Sir, hard disks.
Yes. Hard disk, slowest component is not but your hard disk, right? Hard drive usually. And your fastest component, which is that
Cache memory, sir.
your CPUs actually. CPUs are the fastest actually. Next to CPU, you can say that RAM is the fastest, component of your laptop or your server. We say, right? So now, so if you take it actually, see, for example, if you have the same thing, like if I take the example of the same thing, okay, or else what I will do, I'll have one more MS Paint. I'll try to explain this. So generally what happened, right? We have an application server here like this. I'll take the same application server. What we have is a Tomcat server or any other things we can take application server. Okay, and okay, Tomcats. So we have the same Tomcat server. Okay, I'll take this one. Or there's some noise is coming up here. So you have an application server here, right? Now you know that whenever the application server, it needs some kind of a data. Okay, it needs some kind of a data to be computed. So your application server will always communicate with some kind of a database server. We have a database server here, which will be running, right? So assume that you have something like a PostgreSQL or MySQL or any kind of a database. So I'll take a MySQL actually. So this is a MySQL DB server, right? So this is MySQL DB, right? So this is nothing but your database server. Now, whenever the application it want to fetch any information, what it does basically, it sends a query to the database. So it sends a query. It means that it has to fetch some information, fetch some info. So usually what happens, right? The database, what it does, right? It maintains all the database information, everything into the hard disk, right? Basically, it maintains in a hard drive, right? Right, it maintains in some kind of a hard drive here. So it internally has a hard drive, this server, and within this server, what happened? All the data of your MySQL database, it will be stored in this hard drive in some format actually. Right. So basically, what happened? The hard drive, what the MySQL will do? MySQL will try whenever a user or the application server it want to fetch some data within the database. What the MySQL will do? It will try to send the query or sends a query to the disk actually. So what it does? It sends a query. It queries the disk for the information. Correct, guys? Now, as we know that disk are always very slower actually. So it means that always whenever the application server it fetches the data, it has to wait for some time till the data is loaded into the database, and finally the database is going to like return back the data to the application server. So usually what happened, the communication is little bit slower here. So in that case, what happened, right? You will not be able to achieve the fastness in your applications, right? Basically, you need to wait for some time till the database return the data, right? So when you are computing a large, application and everything, right? You cannot keep waiting for the data to be returned by the database. So what happened? You will see the very slow responses with the applications, right? So in the real time, what happened, right? The client, whenever he works for any application or when he interacts with the application, he expects the application to be very much faster, actually, right? The response of the application has to be very much faster. So in that case, to reduce all this complexity or to reduce the, to reduce all this anomalies, we say that we have something which is a cache server actually. Cache server, right? See, for example, here, if you go to the Amazon site, actually, suppose you go to the Amazon website, Amazon shopping site, actually. So can you see that, over the day, right? Over the period of time, like for example, if you go to the Amazon and if you go to the category here, you could see that this categories, like these categories are all static categories. It will not change at all, right? Like mobile computer, TV, appliance. Hardly in a day or in a 1 or 2 days, they might change some data within this. But the menu or this category, everything will be remain almost same every day, right? So this all these data are kept in a database, right? When there is a data which doesn't change very frequently, the data which doesn't change very frequently, those data, it is better to keep it in a cache rather than keep it on a disk actually. So what they'll do that, instead of keeping those data into the disk actually, what happened, right? And always fetching the data from the disk actually, it is better to keep the whole data into some kind of a cache server, so that whenever the application whenever the application queries for the data, immediately the cache server can give back the data. So you will see a little bit very much faster in response of the application. So what happened, right? Whenever you are actually pulling the data where the data doesn't change frequently, then in that case, guys, you have to keep the data in a cache server. Whenever the data which dynamically, dynamically it keeps changing, right? Keeping in a cache doesn't make sense actually. In that way, or in that case, what happens? The application has to fetch the data from the database itself. Clear? So now what happened, right? Let me write some note on this, whatever I said now. So in the cache server, all the data about the all the data about the application or systems are stored in database, correct? In some format. In some format. Generally, the database stores the information. What is it? The system information on the disk actually in their own format. Okay, so whenever the application sends request to pull the information, one second, pull, yeah, the information from the database, disk IO happens, or disk IO has to happen, and disks are generally slow in nature, right? Slow in nature. So that's the reason what happened, right, guys? You have something known as a cache server actually. Okay, so here what happened basically in the cache server, what you maintain, right? You maintain some kind of a RAM memory. So we know that RAM is faster than disks, correct? Faster than disks actually. So if we store all the data which are changed infrequently, which are changed infrequently, it's not that much infrequent, QNT, frequently, okay, infrequently on RAM actually, or in the RAM, but on the cache, I'm saying on the RAM, then the queries will be much more, I can say faster. Clear? So that's the reason what happened, guys. Here, you have something in between. Okay, let me remove this. I don't want this. Okay, you have something known as a cache server here. Something known as a cache server. Okay, cache server here, right? And here what happened, right? You have a usually generally the cache server is not, but where you have a RAM actually, RAM memory icon. RAM memory, right? So whenever the application it want to fetch the data, it fetch data, and if the data, whichever it is fetching, if it is an infrequent data, infrequent change data, all this data it will get to the cache server. So it fetches data, it gets the to the cache server, right? Now, whenever any data are infrequently all changes, what are the data which is infrequently get changed, right? Then what happens? This cache server will communicate with your MySQL server or to that particular database server. It will communicate it or it will fetch it. It fetches the data and it keeps all the data into your cache memory. It fetches the data when all those datas all infrequently datas, right? What are the infrequent datas are the right? Change the datas, right? Those datas will what the cache server will do will always communicate with your MySQL and it fetch the data and keep it in its RAM memory or into the cache memory. This is how the cache server works actually. So in many of the systems in your right, you might come across with a lot of cache servers actually. So what happened, right? In this case, so in this case, we we introduce a server which loads all the infrequently changed, or we call it the static data, something static data into the RAM memory, into the RAM actually, into the RAM. And when the application server queries QUERIS, right, queries this data, it can give a quick response. Who can give the quick response? The cache server. And that's the whole idea of the cache server. Clear, guys? So what are the popular cache servers? If you go to the net and if you try to search for the popular cache servers, popular cache servers, most popular cache servers, most popular cache servers. How it works? What are the best cache web servers you have? What happened is so most popular cache servers. We have a lot of popular cache servers. So if you go to anything, like you can go here, TechMint also, you will find a lot of like Redis cache, Memcached, Apache Ignite, like that. You have a lot of cache servers are there. So which are the most popular one? So popular cache servers. So the first is nothing but your Redis cache, and even like for example, you have something as a Elastic cache. So these are some of the very important cache servers actually. Okay, some of the cache servers like Redis, like when it comes to Redis cache, like, it will be having an infrequent data also. But sometimes when you are trying to do a lot of computing, which is the in memory, right? So what happened? It has a capability even to write this Redis cache has a capability to write the disk synchronous data onto the disk directly. Suppose an application server is doing some kind of a changes actually to the data. So this Redis cache, which it has some data which was infrequent. Suppose an application server is doing some changes, right? Synchronously, what happened? The Redis cache will try to apply the changes into the disk itself. Actually. So that's the reason what happened. Right? A lot of people in industries they are going with the Redis cache. Actually, it has a lot of other capabilities also, right? Okay. Yes. So now that's all about these two servers actually. Redis cache, sorry, cache server as well as your like your message queues actually. Clear? Now, before getting into other things, guys, I want to tell you one thing that some of you have asked me about the basic things like what are the things we need to learn while understanding or while getting the DevOps. Actually, I have told very important thing that actually that you should be good in Linux actually. So you should be good in Linux. That is very important. That's the foremost important thing actually. So to do that, what I would recommend you that actually first you need to learn Linux. So If you go to the YouTube, actually, you can go to, if you go to my channel. So if you go to my channel here, so if you go to my channel and if you go to the playlist, so there is already a playlist of your advanced Linux scripting actually, which has all the basic concept on Linux operating system, commands, terminal, what, and basic level of scripting. Everything is covered over here. So I would recommend you to go through this, go through this link also. I mean, go through this playlist and try to understand about the Linux. This is very much important actually. So this is the playlist, guys, actually, which you have to go through it. And the next is that actually that the some of the people have asked me like, sir, what where I need to practice, sir, actually, where I have to practice all this stuff actually. So always that if you have a very high configuration a laptop actually, so please go and install some kind of a virtualization software. Like you can install VMware, or you can even install the Oracle Sun VirtualBox software. So after installing it, actually, you can create VMs. Actually, you can create VMs, virtual machines, right? So make sure that you have a minimum of 8 GB or 12 or 16 GB of RAM memory, right? Minimum like Intel, i5, i5 processor should be there, not i3. I would say that i4 or i5 or i7, right? Or else you can even go with the latest AMD's Ryzen actually. That also can go through, but better go through with the Intel actually. And when you're going with the Intel, don't go with the U series for actually. You go with the other series of Intel Pentium, like CPU series actually. Don't go with the U, because some of the softwares, for some reason, it is not supported properly into that actually. The U series Intel CPU. Go with the other series like P is there, some other is there actually. Even I don't know much, but I've got to know that U series doesn't support actually many of the software. So don't go with that, and go with a minimum of 500 GB of hard disk actually. Why? Because that when you're creating a VM, it requires a lot of memory. It requires a lot of hard disk actually. So if you're creating 3 VMs, right, and you are working a lot in that, so make sure that your storage also should be minimum. Minimum storage should be there. So that's the reason I would recommend go with a 512 GB of hard disk, or else go with your 1 TB of disk actually. So that is a basic requirement for any of the DevOps engineer to learn actually. So either you can go with this, okay, you can go and create the VMs and start practicing about it. Either you can go with the Ubuntu, installing Ubuntu, or else you can go with the CentOS. These are the best operating system which you can work on to learn on any Linux concepts. After that, what I have to do that, or if this is not there, guys, if you have any questions, ask me. Otherwise, mute yourself.
Sir, hello, sir.
Yes, sir. Yes, madam. Go ahead.
Sir, can you share that Linux link on on chat?
Yeah. Okay.
Okay,
So
sir.
what I was trying to say that, please, these are the basic necessity actually when you want to learn about the DevOps and thing, right? Linux is a very basic, Linux and even Windows also. I have not recorded the Windows for the Windows, so I will record it after some time. But at least Linux you can go to this playlist. So I've already pasted in my chat, so that you can go to that. You can go through this actually. It has a lot of videos. It has around 16 videos are there. So go through all these videos. It is very good, okay, for you to learn about Linux operating system. So or else, and how to practice, that's what I'm saying it. So this is a very basic thing. I think in last 2 3 days, a lot of people pinged and asked me about what to do. So I thought that in today's session I will cover this actually. And even some of you guys asked me about what kind of a laptop configuration I have to take. So I just no, I just told you about the configuration. So you can go with any laptop. Either you can go with your a Lenovo laptop or Dell or any other laptop. So it doesn't, there is nothing like that. You have to go with that specific laptop. So, but your laptop should have little high configuration, because you might end up with working with a lot of servers, right? So in that, what happened, right? You need to have some good amount of, resources in your laptop. Like CPU should be minimum i5 should be there, minimum 512 GB of RAM, hard disk should be there, and also you should have a good amount of RAM memory. I would suggest you to go with the 16 GB rather than 8 GB or below 8 GB. Don't go with the very low RAM memory, because you might need, you have to work with a lot of things, right? So you need a very good RAM memory also. Okay. So apart from this VMware or working with a VM, some people might say, sir, why don't I practice in the cloud? Yes, please practice in the cloud also. That is very much important. Ultimately, you'll all will be getting into working on the cloud. So you need to please create an AWS account also. Create an AWS account. free tier account and practice in it. Okay, or else we can even go with Azure. Please create Azure account and practice it. So some of you might say, sir, I will go with Google Cloud. Yeah, it's your choice actually, Google Cloud. You can go with any cloud technology, sir. Nobody will stop you. You can go and create a cloud account, Google Cloud account, and you can practice it actually. Or else somebody might say that, sir, I will go with the DigitalOcean. It's left to you guys. Whichever you feel feasible, go with that specific cloud and then start create your account and start creating a machine and start practicing whatever you want. Clear?
Hello, sir.
Yes, clear, sir. Any question here?
Yes, sir. Sir, I have a laptop of AMD CPU, but sir, when I'm creating like a virtual box, so it will show some error.
Mhm.
And so I think some Linux are not supported by like AMD CPUs. Means
Yeah,
not
that's what
optimal.
you go with the latest Razer. This is that. Don't go with some older one. Okay. There could be multiple things, or even like if you try to triage the issue, right, why it didn't go right, you will find a lot of it. It could be, sometime it could be an hardware issue, sometime it could be a processor issue. I mean, hardware issue in sense like the BIOS might not be supporting properly. Maybe, right? Have you enabled in the BIOS first? You have to go and enable the virtualization in the
Yes,
BIOS
sir.
first. Once you enable, then only what happened, right? Your software will work actually. So that's the first thing. And second is that actually it depends upon the sometime what happens, some virtualization software doesn't properly
Yes,
works
sir.
under that particular processor also.
Yes, sir.
So that's
Sir,
what I would, yeah. Yes, sir.
sorry, sir. Sir, in my my operating system is Windows 11 Home, so Home doesn't support virtualization.
Hmm.
So you need to upgrade either to like professional or like you can go with dual boot also.
You can, yeah, dual boot is possible, but how come it is not supporting Windows 11? It should support, right? It's a home
Sir,
edition you have.
hypervisor window provided by the Windows not supported in Home version, only in
Oh, okay.
professional.
Okay. I was not aware of that much because I am not that much a Windows user. But I will check that, sir. Right? Or else you can go with the dual also. What you said, right? You can have a, if you're having a disk, right, and if you have a free disk actually, install the Ubuntu or install the CentOS, and you will have a dual operating system in your machine. You can boot with your Linux and start working on that. But again, as I said, right, it needs a good amount of RAM memory and a good number amount of disk should be there whenever you're having a dual operating system,
Yes, sir, that is
right?
necessary.
Yes, that is necessary. Or else better to go with the AWS or Azure or any cloud account. Do it there also, can play with that. That will be the best actually for you. But some people, what happened, right? They have to try out everything like without paying any money, or they don't want to really get into the cloud. But see, ultimately, what happened today or tomorrow, you all have to get into the cloud. That is a mandatory requirement. So let's start learning the cloud from the day one onwards, like today onwards. Like why you have to wait? Clear? So guys, okay, fine. Now, what is the next thing? What we are going to learn? We will learn about something known. We will be learning about the load balancer. What are load balancers? Very important actually, because in the industry you might have seen that we will be working on a lot of load balancers, right? So uh, before writing down anything on the load balancer, we'll try to understand what exactly a load balancer does actually, right? What exactly a load balancer does. So let me again open MS Paint. So we have something known as a server icon. Okay, so let me choose some server icon image. I'll go to the image. So let me take some server. So let me take this as a server. So this is my application server, or this is my server actually. Here, and this server might have an IP address, something IP address as something like 192.168.10.100 something, some IP address. Okay, and You can even write some host name also. So the host name is not the machine name. Okay. You can have something, how I can say something like, suppose assume that this server where you are running some important, you are running some application where it is a insurance application. Okay. So the server name would be something like insurance dot something rs.com something. Okay, this is a host name actually. Okay, and this is IP address. And on top of this server, right, you will be running your application actually, right? You'll be running your application. So this is your application or the service or the app, whatever you say, application which is running. Correct. Now, guys, whenever an application is running into the server, suppose that you have some kind of a client. The client want to communicate with this application server, right? You have a lot of clients, right? You have a browser client, like suppose you have a Google Chrome browser. It's a client. It acts like a client, right? So right. So have your client. So this is nothing but a client. Correct. Now, whenever your client it want to communicate with this application, how it communicate with the application? It can either communicate with the application with the IP address or with even with the host name also, right? Like for example, whenever it want to communicate with this application, how it communicates. So what you're going to do, you'll open your browser and in your like in your browser bar, right? You will type what you'll type HTTP something like colon or HTTPS 192.168. You will hit the IP address, right? So you'll hit the IP address from your browser. So once you hit the IP address, what happened? Basically, the communication happens from your client to this server actually. So this we call as an application server where application is hosted, right? Or else what you can do, if you want to communicate not with the IP address with the host name, you'll just say HTTP colon double slash something like insurance dot rs.com, something like that. You will hit in your browser where what happened, the client will start communicate or it get connected to their application and it start working, right? So what happened, right? Okay, fine, all these days you are the only client, you are communicating with this application server. But as and when what happened, right, if there are n number of clients gets added on every day, lot of users are there who want to communicate with the application server, right? So in that case, what happened, right? Maybe what happened, right? Your server might not sustain so many number of connections from the client. Maybe like some 5,000 users want to connect to the application server. So the application server might go down, or it might not properly, it might not properly respond to all those 5,000 requests at a time. So in that case, guys, what you will do, you will tend to increase your application server. Instead of having one application server, you say, sir, I will have two application servers. Clear? So now what I'll do that, let me write the scenario. So what are the scenarios? What are the scenarios we have? So the first is that actually we have an insurance application running on a application server or web server, whatever application server, and the users can access this application by using something HTTP colon double slash slash, give the IP address, right? Or give the host name. Like this is a format, right? You'll hit with this IP address or with the host name actually. Correct? So this is how you communicate it actually. So somebody might ask you, sir, I'm why only HTTP, sir? Why not HTTP? Yeah, HTTP is like you need to do a secure communication, right? Definitely you have to use HTTPS. For that, you need to add on a lot of other things to make it a HTTPS work. But I'm saying generally, whenever you are communicating with some kind of a client and server, the basic protocol what is used is not but HTTP. Later, we will make it more secure, we will make it more reliable. Then you need to add on something. You need to install some kind of a software, other softwares. You need to install some certificates, everything to make sure that HTTPS works. Right. So now, fine. Now what happened, right? As I said, like all these days it was working fine. Now suddenly what happened? The n number of clients keep getting incremented. So what you will do, guys? You will tend to increase your number of applicant server. So what you will do here? So okay. Here I'm just doing 2. You can do 2 or 10 or whatever possible, right? You can do it actually. So it's not like that you have to, okay, it's not like that only one server. So you can have multiple servers. In this case, I'm just making as only one more server here, just increasing that. So right. So okay, I think I have to. So 1 second here. Let this IP address be 192.168.10.0. The host name I need to give down because we are added one more new server. You will keep a different host names now. So what are the host name you'll keep? So you'll keep something as a insurance something insurance 1.rs.com something. So this is the host name which you are given for this server, and let the IP address be same 192.168.0.100. And this one, this IP address something like I will for this application server, you will give the IP address as 192.168.10.1. Okay, and the host name is what is it? Something insurance 2.rs.com something. So this is the host name given. Okay, guys. Now, so this is what it means that based on the number of clients, right, or based on the number of increment of the users, you will tend to increase the number of application servers, right? So here in this case, I've added 2. You might have 2 or 10 or 100 or whatever the number, but you will tend to increase the number of application server. Now the question comes that whenever your application server it want to interact with the application, right? Does it interact with this application onto this IP address that is 192.168.10.100 or onto this IP address? How it will decide to which IP address or to which server it has to connect? Guys, you got the question? How the client will know that to which application server I have to get connected so that I can access that application?
Here, load balancer we use, sir.
Correct. But how the application, is there any mechanism where you can tell to the client that, okay, you connect to this 192.168.10.100 to get that access the application, or else you tell to the client that, okay, 192.168.10.100. There could be a number of servers. You cannot really say that, okay, maybe what happened that this application server might serve the service for this client. But sometime what happened that this server might be busy because there are n number of requests pending. It might drop the request being sent by this client. So you cannot tell, you cannot guarantee onto which server it can communicate. Correct? So in that case, what happened, guys? Okay, what happens that you will have something known as a load balancer. Actually. So load balancer is kind of a server, or it's like a software you need to install it actually. So you can take any image. So this is a load balancer actually. So load balancer comes in between like this here. Okay. Now what happened, right? You will, whenever the client want to communicate with the application server, what the client will be told that you send a request to the load balancer, or you'll send the request to this load balancer. So what you will do, you will just say something like http://insurance.rs.com. Like that, you will just hit this URL. So as soon as you hit this URL, what happened, right? The connection request will go to the load balancer, right? This is your load balancer. So I'm not telling in, I'm just telling in a very high level, guys. So what happened, right? Once the request is received by some client to the load balancer, now the load balancer can best decide how to connect to this application. So either the load balancer can send the request to this application server, or else it can send this the request to this application server. So which whatever the logic it has. So basically what happened, it has some kind of an algorithm. So using it, some algorithm, the load balancer will best decide, okay, I can send the request. I can forward this request, what was sent by the client, to this applicant server or else to this applicant server. You might have heard about something like round robin solution, right? So basically, if the load balancer is configured to the round robin, what happened, right? If the first client is connecting, it has to connect. What the load balancer will do, load balancer will send the request to this applicant server. Now there's one more client, is a client 2. It has to communicate or it has to connect. So it sends to the second server. Third request will become, or it'll send to the third server. Fourth request come. In the round robin fashion, it does the work actually. Or else maybe what happened, the load balancer can best decide, okay, whichever server where, like where the CPU or the memory is free or where there is not much computing is happening. Okay, let me send the request to the particular server. So there are n number of different, algorithms are there. Based on that, what happened, right? The load balancer can best decide where I can forward that request. Clear, guys? Okay. Okay. So we'll do one thing. We'll write the notes, whatever I said now. Okay, what I said. Okay, when number of users are increased on one server, then the server cannot handle the load. So we increase the number of servers running the same application. Correct? It's not like that. It will be having the same application, right? So the problem is how the user will access the application. Okay. So something like using which IP address or host name, right? So it doesn't know, right? Either you can hit to this IP address or to this host name, or either the client can hit to this IP address or to this host name. It can use any kind of a host name or IP address to connect it actually.
Hello, sir.
Yes.
Sir, can you show the diagram, sir, once again? I have one doubt, sir. Sir, in when we hit no, sir, like http://insurance.rs.com, so we can't give like insurance1.rs.com so that we can get direct whatever we want that server, no, sir?
Correct. But what happened? The host name or the IP address will be hidden from the client, right? Do you think that this all will be exposed to the client?
Yes, sir.
There could be 100 servers, right? 100 servers has 100 IP address and 100 different host names. Do you think that it will all be provided to the client, to the customers?
No,
right?
no, sir. Correct.
Do you have something known as a? I want to ask a very simple thing. See, Google has many servers actually. You know that does a Google expose saying that, hey, please hit the google.com to access the application, or please do the Google to. No, right? It only say that please
No,
hit
no.
to the google.com only.
Yes, sir. Got, sir. Okay.
Right? Okay. Now, so where I was, madam, when the number of users are incremented. Yes, sir. Go ahead. The servers cannot.
Sir, can you, sir, please go to the, sorry, sir, diagram, sir. Sir, in this, sir, where is DNS resolver work?
Yeah, that and all will come, sir. DNS, what is DSCP and all, we'll see it actually. Yeah, it's a good thing what you asked, but we will see.
Basic thing of DNS flow. Okay, how the registry happens and how the public IP gets resolved to a load balancer, how the NATing happens, how the lower VIP.
That all will come, sir. We'll have to come one by one.
So yeah,
This
that's
I'm
what.
telling you in a very high level, sir.
Yeah. You told, sir. You told.
What
Yeah.
is, sir?
DSCP, DNS, and all those things will come into the picture, sir. So even you can see that here a lot of networking also come into the picture here, right? But we are not discussing on networking, right? So slowly, one by one, we'll do it actually.
Good.
So now, yeah, come back when the number of users are increment. Okay, the problem here is that the user will access the application, user it. Okay, fine. Using which IP address or host name? Correct. Yeah, correct. Host name. So what I have to do? Okay, so this problem will be resolved by load balancer. Correct? Okay, good. So now, so what the load balancer does? Load balancer will redirect the traffic sent to it and distributes among multiple uh, multiple servers depending on the configuration in the load balancer. Correct? It depends upon the configuration, what you have configured in load balancer. Depend on that, it best decides like how to forward the traffic to the servers actually, right? So one I just told about the round robin, right? So we have not yet come into those things, guys. So how exactly the load balance internally works? What are the rules you can set actually, right? And what are the different uh, configurations are there through which you can do? And what is an algorithm used? Everything that we have not come to the picture. We're not discussing all those things now. I'm just telling in a very high level how exactly the basic the basic idea about like what exactly load balancer does. That's what we are discussing here. Okay, and after that, what is there? We have load balancer basically are of two types. Correct? What are those? The first is nothing but the layer 4 load balancer. Okay, like in the okay, we'll discuss. And something is a layer 7 load balancer. So what are this layer? What are this layer 7 or layer 4? You might have heard about the OSI reference model, right?
Yes.
In your engineering days also, you might have learned about this, right? So here what happened, right? You have a 7 layers of OSI reference model. OSI reference model icon. Can go with any image. Okay. Yeah. See, can go this. So these are the 7 layers of OSI reference model, right? This was the layer which was this was a OSI reference model. It was designed by the Department of Defense America, right? So this was some kind of a protocol which they use for communicating because during in 1930s or 1920s, right? What happened? A lot of American military forces that they're scattered across the whole globe, and they were trying to find out how exactly we can communicate or we can reach out to our soldiers, right? So we want to exchange our data. So in that time, what happened in 1930s, I think they started developing a protocol, and they designed the model which they call the OSI reference model. Okay, open system something interconnect, OIS, open system interconnect model. So this OSI reference model, guys, it has the 7 layers actually. Like it starts from the physical layer at the very down, and then you have a data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So these are the 7 layers. And load balancer, we have two type. One is a layer 7 load balancer, that is about the application layer load balancer, and other is a layer 4 load balancer, which we call it as a transport layer load balancer. It means that the load balancer which works in a layer 4, which we call as a transport layer, right? And you know that this each and every different layers, it does a specific job. So we are not discussing now what exactly it does a specific job, but
In the layman term, like how you describe this. So if I have a laptop, okay, how where the data link layer comes, my
see
application is
what
on
happened, right?
the
Here, what happened? These 3 layers, the application layer, presentation, and session layer, these 3 layers come in a user space actually.
correct.
So if you copy it and if you like this actually, so these 3 layers, it comes in the user layer or into the application layer like this. Sorry, here like this. What happened? Yeah, like this. So
In
this
my desktop, one application is there. That is this comes in that, right? If I say any application of Windows, I'm accessing it. It comes in this layer.
correct.
Okay, correct. So the transportation, it comes into a network transportation. When I do a transportation of any data to any other server, that comes into layer. Okay,
Yes.
using that network layer. Okay, and the
Yes.
data link layer is where the physical data where
Correct.
where our Ethernet port will come into picture, right?
So
And
we,
the cable will
sorry, a good name. We are not
Suresh.
discussing everything now. Praveen, huh?
Suresh.
Suresh, we are not discussing anything now. All those things we are just discussing about like load balancer. This and all I will come into the picture when I start explaining about the networking concept and all, right? What is OSI reference model is there, and what is a TCP IP model, right? And what are the different protocol? Like we have a TCP protocol, UDP protocol,
Okay,
mainly.
sir.
So those things, and like we will be coming over some concept on the router, switches, hub, like what is the topology, right? There are many things are there which comes in networking. So there I'll be discussing, in a very better way. We'll be discussing about each and every layer. So what you said is right. What are all the things you said is right. Okay. So now what happened, right? Here okay. So layer 4. Sorry, we'll go here. Yeah. So what I can do here. So layer 4, like it operates on transport layer, correct? As per the diagram, as per the OSR symbol, it works on the transport layer. So this load balancers works, or this load balancer understands, I can say not work, understands the IP addresses and ports, port numbers, ports using TCP. Correct, guys? And this layer 7 load balancer, this not operates, and this layer 7 load balancer operates on application layer, correct? So this load balancer understands HTTP protocol. Which means it understands the URI, or else we call it the URL. Correct? URL. Okay. So basically what happened, right? So whenever you are actually you are having some kind of an application where you want to access that application using some kind of a port number or some kind of an IP address, then you will be working onto the layer 4, right? Whenever you are communicating to a web, you want to communicate to the web or the application which which is exposed through a HTTP, then you have to go with the layer 7 load balancer. That's how you say it. So let me write that one, what I'm trying to tell here. So this layer 4 load balancer, it is used actually. It is used if the load balancing is done to the web or the app servers on port numbers or IP addresses. Correct? Similarly, the layer 7 load balancer, it is used if the load balancing is done to web or app servers which exposes the HTTP, or which is exposed to the HTTP. Right? So what are the popular load balancers we have? So what I was trying to tell here is that, like if you go to the diagram here, if you say that actually if this application, if it want to communicate with particular, if this client would want to communicate with a particular application with some kind of a port number, like, so it uses the TCP, right? So TCP on port 80, right? So then what happened, this load balancer, okay, it knows that actually to which application it has to forward, to which application server it has to forward. So it basically what happened, right? It knows that actually. So the load balance will show that, okay, 80 port. So 80 port on one of the two servers. Like that. Okay. If it is purely on basically on your URL itself, So then the load balancer understand, okay, to which application server it has to forward. Basically, it depends upon the type of load balancer what you're using. Either you'll be using the layer 4 load balancer or layer 7 load balancer, like that. Okay, guys. Okay. Now, for example, assume that you have this application server, right? You have this application server. So you might be hitting the URL http insurance.rs.com. So your load balancer will understand, okay, where I have to forward that request to that particular application server. It understands that because based on the URI, right? URL or URI, it understands where to do it actually. Assume that you have one more application server. I'm just telling you. Assume that you have one more application server like this. Sorry. You have one more application server. So let me take this image and I'll have one more application server like this. Okay. And in this application server, right, you have an application here, the same application actually, but with some extend functionality you have written. So you are having some application here, same application, where what happened, right? You might have set some kind of a contact information. Like for example, like you for every application, right, you'll also maintain a contact information, right? Suppose somebody want to contact you, right? Something like contact us, or else sometime like you want to do some kind of a payment, right? You will have something like you will have a separate URL for the payment, right? So payment, how to do the payment, everything. So what happened, right? Along with this insurance, you'll also have some kind of a contact us information or the payment information which you're maintaining the particular server itself actually. Correct? Now, when you say that, sir, when I'm hitting this URL, http://insurance.rs.com/contact us, right? So there, in this case, what happened that in this load balancer, you already configured the layer 7 load balancer. So the layer 7 load balancer, it works here in this load balancer. It knows that, okay, whenever this request comes from the client, actually, whenever the request will come, the load balancer will know that, okay, I need to redirect that request to this application server, where it can get the information about this contact us web page actually, like that. So here what happened, right? You're purely working onto the layer 7 load balancer. Whenever you're working onto the port or the IP address, right? Then you, in that case, the layer 4 load balancer works actually. Generally what happened, I have seen 90% of everything, right? Whatever the load balancer works, it purely works onto the application layer load balancer. It means that you are purely working, most of the time you'll be 90% of the time you will always be working under the layer 7 load balancer. Clear, guys? So what are the popular load balancer we have? So we have a lot of popular load balancer. Like one of the popular load balancers is F5. You might have heard about, or HA proxy load balancer, and we have something known as a AWS Elastic load balancer, which is nothing but Elastic load balancer. I think it is both a layer 4 and layer 7 actually. Layer 7 load balancer. We have something known as a AWS application load balancer, which is nothing but your layer 7 load balancer, AWS. And same thing, we have a AWS network load balancer, which is nothing but the layer 4 load balancer. And we have, of course, we have Azure load balancer. Yes, Azure load balancers, which is again, it is a layer 4 load balancer. And we have Azure application gateway.
Hello, sir.
But your layer 7 load balancer. Yes, sir.
Sir, I have a question. Means load balancer are in both type, physically or software?
Both, sir. Both we are having physical as a software. I'm not really discussing about physical or the kind of hardware.
Sir.
Like we are
Okay.
only discussing on the software part actually.
Okay, sir.
Okay, guys. So what we're going to do, like I just explained a very high level, not very in-depth level. So we will be learning about how exactly this load balancer works. Okay, we'll try to work with any one of this load balancer, right? And it can explain you how exactly it works, basically. So I thought I will cover even the cloud computing also, but I think it's already 11 o'clock. So we'll stop it here and we will continue our session today evening from the cloud computing, right? What is our cloud computing? What different systems we have, everything, we'll be learning that one. Okay, this itself will take around 1 hour for me. After that, I'll be even taking up like what are about the packages. So whenever you have a software code which is built by the developers, you need to package it, right? How you do a packaging, what exactly is packaging is all about. That is also very much interesting. We have to learn, right? We have to understand how the packaging works, the software package works, and what exactly the DevOps engineer plays a roles when it comes to the packaging, whether the packaging is done by the developer or whether the packaging of the software is done by the DevOps engineer. That also we'll discuss. So there are a lot of interesting stuffs are there which we'll be discussing in this section. Clear? So guys, we'll stop it here now, and then again we will continue our next session today evening at 7 o'clock. Clear?
Okay, sir.
Thank you, sir.
Thank you.
Thank you. Thank you so much, sir.
Thank you. Bye.
Thank you.
Let me stop it. Yeah.